Professor Cesarsky. Welcome to Beijing. I'm very glad to interview you. What do you think are the most important achievements in the astronomy field in recent years? And what is their significance in helping humans understanding the future?
Astronomy is at the moment in an explosion of knowledge. There are many new facilities, there are also a lot of brains, there are possibilities for calculations much beyond what we could do before with the expansion of computers. And the universe now appears at hand, something maybe one day we can really understand. Among the very many discoveries there have been recently, I think there are two that are outstanding. One of them is the fact that the expansion of the universe, about which we know since at least 1929, is accelerating. For many, many years, we thought that this expansion, the universe was expanding, but that eventually it would slow down the expansion. Perhaps even it would completely stop and come back. And observations in the last 15 years, different kinds of observations of supernova remnants, of supernova explosions, observations of the background radiation left by the original explosion of the universe, the Big Bang, also observations by looking at surveys of the position of galaxies and structure in the universe. Three different kinds of observations led us to the same result, that this acceleration is expanding. So why is it expanding? Because that it would slow down, we understood it would slow down because at first there was an explosion, there was a push, but the gravity is trying to bring the matter back, and so it should slow down. If it in fact accelerates, it means that in addition to the gravity which would push to slow down the expansion, there must be something pushing out. And we don't know what is pushing out. We call it dark energy, which is one way of declaring our ignorance. So before, we already knew that the universe is made mostly of matter of totally unknown nature to us, which we call dark matter. And this has been confirmed through the years. But now we know that in addition to this dark matter, an even bigger part of the energy of the universe is in the form of dark energy. And so I said maybe we will understand more, but perhaps it's the opposite. We know better that we understand less the universe. And when we will study further and further these problems, we expect revolutions in our thought about physics, and therefore about the whole world. And this is also the world we live in, the universe we live in, and therefore I think it's important for all of humanity. So this is one important discovery. Another one, which I absolutely wanted to mention, is that also in about the last 15 years, we've entered in a new world. I mean, before, there were the solar system and its planets, and these were the only planets we knew. And we always supposed that there should be planets elsewhere in the universe, that the other stars should have planets, but now we know. It has been known for a long time that one way to know would be to look very carefully at stars and measure their velocity. Because if a star has a planet around it, the star attracts the planet, and this is why the planet is in orbit around the star. But the planet also has an effect on the star. So the star is not just standing there, it's also moving a little bit because of the effect of the planet. And this effect we can measure by measuring very carefully the surface velocity of the star. So for years, astronomers have been improving and improving the way they were doing this measurement. And about 15 years ago, Michel Mayor and Didier Queloz, two Swiss astronomers in a French telescope, were able for the first time to demonstrate that there was a planet around one star other than the Sun. Since then, the work has expanded enormously. Other methods for this indirect detection of planets around stars have been developed, and now the number of extrasolar planets that we know is increasing so fast. I think we are at 700 or 800 Especially now, there is a satellite called Kepler, which is discovering them by enormous numbers. But the ground observations continue to make more and more discoveries. In the beginning, the first planets to be discovered were very large, planets like Jupiter or even bigger than Jupiter, and Jupiter is the biggest planet we have here. Because of course it's easier to discover a big planet, and especially if what you are looking at is the effect of the planet on the star, the biggest and the closest to the star, the more effect it has and the easiest it is to detect. So this is what was detected first. But as we improve and improve the methods, and this is what is really happening, in particular at ESO, the European Southern Observatory, where very accurate spectroscopic observations are being made with an instrument called HARPS, it becomes possible now to detect smaller planets, more far away from stars, so things that resemble more the Earth. We are not yet at planets of the mass of the Earth, but we by now know many planets which have masses of the order or less than 10 times the mass of the Earth. We call them super-Earth. And now some of them are even in a region which we believe could be habitable, in the sense that the water, if there is water in those planets, it would be in a liquid form, and we believe that water is important for life. So this is a fantastic subject, and it has also a fantastic future, because soon we will be able to observe, we believe, the atmospheres of these planets, and therefore try to understand better whether there really is life on them. And of course, the importance for humanity is obvious, because I think we have always wondered, are we alone in the universe? And we are not on the border of discovering the existence of beings like ourselves in other planets. This I really don't believe. But I think in the relatively near future, we will be able to say if there is at least life of some form in planets all over our own galaxy.
Yeah, it's very fantastic. Yeah. Okay. Is there any division of work and collaboration among global astronomers? What role is IAU playing in astronomy international cooperation?
Division of work is perhaps too strong a word, but there are two important things that are happening. One has to do with large-scale installations. Astronomy is advancing so fast, very much thanks to technological advances. And astronomers are very good at using discoveries in all kinds of different fields and apply them immediately to their field to have more and more accurate observations. But as we want more complicated observations, also very often it becomes more and more expensive. And then, different countries cannot afford to build each one their own facility, so countries get together. And this, for instance, in Europe has happened for a long time with organizations like ESO, which does ground astronomy for all of Europe, or ESA, which does space astronomy for all of Europe. But now, more and more, it even happens at the world level. There are some world facilities. For instance, in March next year will be the inauguration of ALMA, which is a facility to make maps in millimeter and especially in sub-millimeter range. So this is done with radio telescopes, which antennas which look like the communication antennas that everybody knows, but which are brought at a height of 5,000 meters to go to a region very dry and with very little water vapor between the telescope and the universe we want to observe, to be able to see what has been happening in star formation in nearby galaxies, or even in star formation in very, very far away galaxies, because in this range of wavelength one can see the very earliest galaxies in the universe. So this facility is going to have 66 of these antennas, and to build it, an agreement has been made between ESO for Europe, the United States through NSF, Japan, Taiwan, Chile, of course, participates because this is in the Andes Plateau in Chile. So it already starts being quite worldwide. And there are discussions now for a very, very large radio facility called Square Kilometre Array, which will be partly in South Africa and partly in Australia. And there also many, many countries are involved, including China. And since it hasn't completely started, there could be even more countries that will join. So it will be even more of a global endeavor. So this is in terms of facilities. The other subject where everybody collaborates, and which I think is extremely important, or everybody has access, is that more and more the astronomers who make observations don't just keep the results for themselves to write their own paper. Most or many of the very important facilities make the data available to everybody. And astronomers also get together to organize very well the software and so on, the way they are making this data available, so that it is easy for astronomers to obtain data from any satellite or any ground facility they want anywhere in the world, and also to have the possibility to quickly see one object in the sky, so what happens in X-rays, what happens in gamma rays, what happens in the infrared, what happens in the optical, etc. And in this way, there is this treasure of results, which is enormous, because we are retrieving now so much data, that all the astronomers in the world are sharing. Then about the role of IAU. So IAU, of course, at minimum, gives a forum for all the astronomers to discuss. And one of the most important parts of it are these general assemblies, which organize a big meeting every 3 years, attended by more than 2,500 astronomers. This time we have even more than 3,000. Often we have, more, in various parts of the world. And there all the subjects are discussed, and astronomers can find out the news in their own field, but also the important news in many other fields. And everybody can get together, because really the whole world is represented at our meetings. And in these meetings, we have in particular discussions about these large-scale installations. So it's a good place to agree that this large-scale installation will be built by many countries, and this one even by many continents, and so on. So discussions can take place here, or through IAU in other places. And also there is a lot of discussion here about what we call the virtual observatory and the way the data retrieved by everybody can be accessed.